Good day, good day. Let's quickly do this question. Question number 9 of September 2023. This is electrolytic cell. Okay. The electrolytic cell shown below is used for electrolysis of CuCl2, that is copper chloride. This is the cell. Then we have this side, which is a negative, then this one is positive. So the positive electrode is the anode. The positive electrode of electrolytic cell is an anode. Then the negative electrode of electrolytic cell is the cathode. Okay, so we have electrode A, which is a cathode, then electrode B, which is an anode. A and B are carbon electrodes. So this electrode is made up of a carbon, and this one is made up of a carbon, meaning that the electrodes are not active. These electrodes are not active. They are not active electrode because carbon is not there in electrolyte, in the electrolyte. This is the electrolyte. In the electrolyte we have CuCl2. There is no carbon here. If there was a carbon, we will say the electrodes are active, but now there is a copper here and a chlorine, and the electrodes are carbon electrodes, therefore the electrodes are not active, meaning that copper and chlorine will take part of this reaction. One of two will be oxidized, the other one will be reduced. Okay, so when the electrode dissociate lapha emanzini, we are going to get the Cu2 plus and the Cl minus. Therefore the negative one will go to the positive electrode, which means chlorine will be stuck here, forming the bubbles. Chlorine gas will be there. Okay, the chlorine gas will be formed at B. Okay, then Cu2 plus, this one is positive, will go to the negative, which means here we'll have Cu, which is formed there. There will be a layer, a brown layer there. Okay, since this one is an anode, we say an ox, which means oxidation will take place here. Therefore we'll have 2Cl minus, forming Cl2 plus 2 electrons. That is oxidation reaction. That is an ox. Therefore the electron will be at last. That is because an ox the electrons will be on the product side. So let's come to this one. Here we say red cat, meaning that reduction will take place first. That is the gain of electrons. So we have Cu2 plus 2 electrons to form what? Cu. So electrons is lapha ekuqaleni because red reduction sewuqaleni. Here electrons lapha ekugqibeleni ku-products because ox usegqibeleni kula magama ethu, that is an ox, red cat. Okay, so now we can go to answer the questions. The first question says define electrolysis. Electrolysis is the process whereby the electrical energy is converted to chemical energy. Is the process of electrolysis exothermic or endothermic? It's supposed to be endothermic because there is that power source that supply energy here. So this is endothermic reaction because the energy is absorbed from the surrounding. The answer is endothermic reaction. Write down the half reaction that takes place at B. This is B. The half reaction there is 2Cl minus to form Cl2 plus 2 electrons. This one is answered. Then they say a 0.369 gram of Cu is deposited on the cathode in 27 minutes. Calculate the electrical current used during this process. Okay, I'll first write the steps, then we continue. Step number 1, when you see this question, that is question number 9, calculate the first step, that is number 1. We are going to calculate the number of moles. Number 2, we are going to use the mole ratio. Number 3, after the mole ratio, we calculate the number of particles, that is the number of electrons. Okay, so we're going to use N is equal to N over capital letter N. That is, we are calculating the number of particles, in this case number of electrons. Then number 4, we are going to calculate the charge from the number of electrons using the formula N is equal to Q over QE, meaning that this N now is number of electrons. Here the number of electrons is this N. Okay, this N here is the number of moles, right? Okay, number of moles. There's a difference between this N and this N. This N, this one, this N, small n there represent the number of moles from paper 2. From paper 2, this one is from paper 1. So that N represent the what? The number of electrons. Then let's go to step number 5. Then we'll calculate what? The current now. So we can calculate the current using I is equal to Q over delta T. So I is the current. Now let's answer the question. Step number 1, we're going to calculate the number of moles here. So number of moles, N is equal to M over capital letter N. Okay, so N is equal to M. This is the mass. So the mass is 0.369 grams. Okay, divided by the molar mass of the copper. Let's go to the periodic table. This is the copper, this is the molar mass. So it's 63.5. So we have 63.5. Then the number of moles of Cu is equal to, press calculator, 0.369 divided by 63.5. So then we get the answer, which is 0.0058 grams. So that is step number 1. 58 mole. Okay, so step number 2 says use the mole ratios. Now we're on step number 2, that is the mole ratio. Remember that we said Cu, we have Cu2 plus 2 electrons, then we get the Cu. Now we have the number of moles of the copper, that is 0.0058, but we need what? The number of electrons. We have these 2 here, the ratio is 1:2. 2 is to 1. These 2 here, there is 1. So we have 0.0058. That goes with copper. Then below 2 we have N. Then we can cross multiply. N times 1 is N. So N is equal to 2 times 0.0058. The answer is 0.01162 moles. That is step number 2. Let's go to step number 3 of this question. Step number 3 says use N is equal to N over NA. So N is equal to capital letter N over NA. So this N is the number of moles, this one is the number of electrons, then this one is Avogadro's number, which is constant. Now we are going to write here. So the number of moles is 0,01162, which is equal to number of electrons over Avogadro's number is 6,02 times 10 to the power negative, or it's not negative, to the power 23. Then we cross multiply. There is 1 here. 1 times n, that's supposed to be n, which is equal to 0,01162 times Avogadro's number. Then we get 6,02 times 10 to the power 23. So my calculator gives me, if that is correct, let me repeat it, 0,01162 times 6,02 times 10 to the power 23. Okay. So the answer is we have 6,9964 times 10 to the power 21 electrons. Then we can calculate a charge now. N is equal to Q over QE. This is the number of electrons. We take this number here, so we have 6,9964 times 10 to the power 21, which is equal to Q over QE is constant, 1,6 times 10 to the power negative 19. Then press the calculator, then the answer Q is equal to 1119,43 coulombs. Okay, then we go to the formula. I is equal to Q over what? Delta T. So remember that we said this one is step number 4 to calculate the charge. Then we go to step number 5 to calculate the what? The current. So let's substitute. Q is 1119,43 divided by the time, which is 27 minutes. Then we convert to seconds by multiplying 60, which is equal to, then press calculator, the answer is 0,69 amps. Then the question is answered. Thank you. Let's check another question.